of sine of x is cosine x. And I'm using x here as a variable. You can replace x with whatever other variable you want. Just make sure that you're taking the derivative with respect to that same variable. So this is single variable calculus here. That actually is an important point. But if you are clear with which variable you're working with, then another shorthand notation is sine x prime. So that first prime is the first derivative, but that is that only works if you're taking the derivative with respect to the given variable, in this case x. Okay, so the derivative of sine of x is cosine x. Okay, and then the derivative of cosine x is, I'll give you a second to quiz yourself, and I will also write cosine x prime. That would be negative sine x. Okay, so the derivative of cosine is negative sine, and the derivative of sine is cosine. Very good. Okay, so now for our other four trig functions, we are going to write their definitions in terms of sine and cosine and see what happens. So, the derivative of, let's start with the tangent. So the derivative of tangent is, and so we can just do tangent prime. Just like from before, we're taking the derivative with respect to x. Now, tangent is, by definition, sine over cosine. So I'm not doing anything else other than just writing out tangent in terms of sine and cosine. And so we're going to take the derivative of that. Okay, so is the derivative of this the derivative of sine over the derivative of cosine? The answer to that is no. We do have a quotient here. We do have something divided by something, and we are taking the derivative of that quotient. But we cannot just take the derivative of the top divided by the derivative of the bottom, or the numerator and denominator. We do have a quotient rule for derivatives, though, so let's go over that. So if I have a function of x, I'm just going to call that f, divided by a function, a different function of x. So f and g here, and I take the derivative. So in this case, f of x is sine of x, and g of x is cosine x, and I'm taking the derivative of that quotient. There's a cute little mnemonic that's low d high minus high d low over low low. So what does that mean? It's if the top part is high and the bottom part is low. So low d high means I'm going to take the bottom function g. D high means f prime, the derivative of the top part, minus high d low. So I'm taking the top function, which is high. D low means the derivative of the bottom, over low low, and that sounds better than low squared. So g times g is g squared, so it's g squared. Okay, so we're just using primes here for derivative. Everything's in terms of x, so you could write g of x times f of x prime minus f of x times g of x prime over g of x squared, but that's what this is. It's just kind of shorthand here. So low bottom function di, derivative of the top, minus the top function times the derivative of the bottom over the bottom function squared. Okay, so let's just write this out and just apply this. So the top function is f, the bottom function is g, and let's just use this formula. So g is cosine x times the derivative of the top minus the top function sine x times the derivative of the denominator, all over the bottom function squared, so cosine x squared. Alright, so let's just use the derivatives that we know now. So we know that the derivative of sine of x is cosine x, right? And the derivative of cosine x is negative sine x. So we're just going to plug those in here. So we have cosine x times the derivative of sine of x is cosine x, right? Then we have minus sine of x, and the derivative of sine of x, or cosine of x rather, sorry, is negative sine of x. The negative and the negative cancel. So I have sine of x times sine of x all over cosine of x squared. Now, this is cosine squared plus sine squared. So I'm just going to write that. That's cosine squared x plus sine squared x. And one of our very basic trig identities is that sine squared plus cosine squared, or cosine squared plus sine squared, is equal to 1. So this is 1 over cosine x squared, which you could write as 1 over cosine x, like this, squared, because 1 squared is 1, and 1 over cosine of x is secant, actually, by definition. So this is the same as secant squared x. So the derivative of a tangent of x is secant x squared, or secant squared x. So now I can write that one in. D dx of tangent of x is secant x squared, or you can write that as secant squared x. Okay, very nice. So we are going to do the exact same thing for cotangent. Now, of course, cotangent is cosine over sine, which is 1 over tangent. So we can use other trig rules given the fact that we just found the derivative of tangent, but I want to break this back down in terms of sine and cosine, just so that you don't always have to do this in this particular order. So we are going to get the same practice again for cotangent, okay? So this time it's the same exact thing, but we just have to be careful in how we write this. So cotangent is cosine over sine, or 1 over tangent. But going back to our basic trig functions, cosine and sine, we have this quotient now. So let's do our low di minus high d low over low low. So let's do low di minus high d low over low or low squared. Alright, so in this case, f is going to be cosine and g is going to be sine, and let's just apply the exact same thing. So low di minus high d low over low or low squared. So this is sine squared. Okay, so the derivative of cosine is negative sine. So sine times negative sine is negative sine squared. Positive times negative is negative. So negative sine squared x. And then the derivative of sine is cosine and is positive. So negative times positive is still negative. So negative cosine times cosine is negative cosine squared over sine squared. Okay, well in this case, if I happen to factor out the negative, I have sine squared x plus cosine squared x. Doesn't that look familiar again? There's our basic trig function that this whole top part makes it, this whole thing is 1. So we have negative 1. Sine squared plus cosine squared is 1. So negative 1 over sine squared x, which you can write out is negative cosecant squared of x. Okay, so now let's do the derivative of secant of x. So d dx secant of x, and the definition of secant is 1 over cosine. So we're basically doing 1 over cosine prime. Okay, so this one is a little funny. We do have a quotient here, and technically you can use the quotient rule. The derivative of the high part will always be 0 because the derivative of a constant is 0, and it actually cancels out. So there is a kind of simplified version of this, but the way that I want to do this today is using the chain rule, just for fun here, just so that we can do a different derivative rule. I'm gonna write this like this: 1 over cosine x is cosine x inverse, like this, and then we're gonna take the derivative of that. I might have gone overboard with parentheses, but that's okay. So we're taking the inverse of cosine and taking the derivative of that. So the way I'm looking at this one is I have a function, so it's basically like stuff to the power of -1. So I'm using the power rule and the chain rule. But because stuff is not just x, I have to multiply by the derivative of stuff. So when I take the derivative, I have to do oh man, this is going to be complicated when I write this out. So the derivative of stuff inverse is, I'm gonna do the power rule, so negative stuff to the -2 times stuff prime. Does that make sense? Probably not, but it's basically, if this were x to the power of -1, then I could just use the power rule with the power of -1. So I bring this in front here, and then I reduce that by 1, so it would be negative stuff to the -2. But because this is not x, I have to take the derivative of that stuff. Of course, there's a more formal way to write out the chain rule, but this is basically what we're doing, okay? So, negative cosine of x to the -2, which is just 1 over cosine squared, times the derivative of cosine. So, okay, so I should write this a little bit nicer. So this is basically the power rule and the chain rule. And you really don't have to do this derivative in this particular way, but I really wanted to use this as an excuse to try out all the different rules here in one place. So the power rule is that the derivative of x to the n is nx to the n minus 1. So you bring that exponent down in front as a coefficient, take your x and then raise it to do 1 less than that n constant. And the chain rule is when you have a function of another function, like if it's a composition, then you just take the derivative as you might think it would be, like just the derivative of f, and then you have to chain on or multiply by the derivative of that inner part, because it's not x, it's something else. And so that's what I was trying to kind of highlight here with the stuff is, I know it looks messy, but if you pretend that stuff is x, if you do the derivative of x to the -1, you would do this power rule here. You'd bring the -1 in front and reduce that power by 1. So -1 minus 1 is -2. But because I have stuff and not just x, I have to multiply by the derivative of that stuff. So I was kind of saying it out loud very casually, but this is how the chain rule works. So we're combining these two together here. So I did the power rule right here, and then I did the chain rule because that inner part is not x, it's cosine x. So I have to multiply by the derivative of that. Alright, so the derivative of cosine x is negative sine x. So I'm just trusting the math here. In this case, I have negative cosine x to the -2 is cosine squared. So negative 1 over cosine squared x times, and then the derivative of cosine we just said was negative sine x. So negative times negative is positive, so these cancel. And then I have sine x over cosine squared x. Okay, so what do we do with that? We could just leave it, but we can also just break this out a little bit. So we can do sine x over cosine x times 1 over cosine x. And the reason I want to do that is because these are, by definition, some trig functions. Sine over cosine is tangent, and 1 over cosine is secant. So that is our derivative, and usually we write it the other way. Actually, I'm not sure about usually, but it doesn't matter. I've seen it actually both ways, but it's secant tangent. So I actually like it the second way just because we're taking the derivative of secant. So the derivative is just that same function times tangent, like so. So you just add on a tangent there. Okay, so the derivative of secant is secant tangent. Now we can do cosecant, and it's the same exact process, or that's what I'm going to do today. So let's get that practice in again. So cosecant of x is, we're taking the derivative of 1 over sine. Cosecant is 1 over sine. So I'm going to do the chain rule again. So the way I'm going to write that is sine of x inverse prime. Okay, so I'm going to treat this whole thing, or not this whole thing, just sine of x as though it were x. The derivative of x to the negative 1 is negative x to the negative 2 using the power rule. So I would just write out as though that's what I'm doing. So negative x, but it's not really x, it's sine x raised to the power of negative 2. Then I'm chaining on the derivative of the stuff that I said was x, but that's not actually. So it's chain rule. So we have negative 1 over sine squared x times, and the derivative of sine is cosine, right? So the derivative of sine is cosine x. So now I have negative cosine x over sine squared x. And just like before, I'm going to split it up so that I can use our trig definitions. So I'm going to do negative cosine x over sine x times 1 over sine x. And I'm just doing this because we know the definitions of trig functions up front, so it cleans it up nicely. So when you multiply fractions, you just multiply across, right? So sine times sine is sine squared. Cosine x times 1 is cosine x. And I have my negative. So cosine over sine is cotangent. And 1 over sine is cosecant. So again, I'm going to flip the order of this. I'm going to do negative cosecant, cotangent. But it doesn't matter again. So the derivative of cosecant x is negative cosecant x cotangent x. Ta-da! Alright, so let's go over all of these again. We have the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. The derivative of cosecant is negative cosecant cotangent. You got that? Well, let's do a little pop quiz, shall we? Let's write them all by memory now. So, the derivative of sine of cosine is negative sine. The derivative of tangent is secant squared. Secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. Why do I keep doing that? Secant tangent. The derivative of cosecant is negative cosecant cotangent. And there you have it. We have all of them now. And one thing to kind of notice, just if you happen to be trying to memorize this, is note that here you have I don't know if this helps, but cosecant and cotangent are kind of paired up here. We have cosecant and cosecant cotangent, and secant and tangent are kind of paired up here, right? So the derivative of tangent is secant squared, the derivative of secant is secant tangent, so they're paired up, and the derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. So the C ones here, for what this is worth, are negative. So you can kind of remember that. And then we have the pattern of something squared for tangent cotangent, and then for the other one we have the same function